everyone, welcome back to mathematics, and we are doing International A Levels EDEXCEL Pure Maths 1 syllabus, and we are doing chapter number 1, Algebraic Expressions, in which we have covered these three of the topics. And now today we will be doing Surds and rationalizing denominator. So let's begin. What is a surd? If you have seen any number written inside the square root like this, we can call it to be a surd, but there are some conditions associated with this n that needs to be fulfilled or that needs to be checked, so you can say that it is a surd. First of all, n must be a positive integer. Okay, n must be a positive integer means that it should be like square root of 2, means the thing inside your square root, it must be positive, or it must be like square root 3, but it will never be like minus 7. No, it's not a surd. It's no longer a surd now. Okay, n should not be a complete square. Complete square, you know, are 4, 9, 16, the numbers that we get after squaring the number with itself. So 4, if you will be having a complete square inside the surd or the square root, then it will solve out to give you a 2, the normal number. So it will no longer remain a surd. So that is why your square root must not be having any complete square. Thirdly, n should not be a fraction, means you cannot say this to be a surd, root 2 over 3. It is no longer a surd. Or also, if you will be having 0.54 under the root, it's also not a surd. Or square root of 6.4, it's also not a surd. So any number, if it is any number inside the square root, if it is a decimal or a fraction, then it will not be a surd. It must be a positive integer. It must not be a complete square. Let's talk about some of the examples of surds. So the example of surds would be root 2, root 3, root 4. No, because root 4 will give you 2. Then root 5, root 10, root 19. These all will be called as surds. Surd is actually an example of irrational numbers. What are irrational numbers? That cannot be written in P over Q form. Okay. Also, there how can you say this, that it's a irrational number? Because the square root of n will give you non-terminating and non-recurring decimal. When you solve any surd, you should be getting a decimal that is not terminating and it is non-recurring. So we can say this thing in 3 ways, that it's an irrational number because it gives you non-terminating and non-recurring decimal. So it is an example of an irrational number. Okay. Now next thing, what is about the multiples of surd? Multiples of surd means like 2 times of root of 2, 4 times of root of 2, 7 times of root of 2. So these are just the multiples of root 2, or 5 times of root 3, 12 times of root 3, or 19 times of root 29. So if you can see, these are just not the surds, the square roots, rather some number is also multiplied with it. So if you have any multiple of a surd, it will surely also be a surd. So any multiple of root n will be a surd also. Multiple of root n is a surd. Now we have already discussed examples. So what we have discussed so far, what are surds? When your n must satisfy these four conditions, then we know the examples. Then we must know that square root n is an irrational number, is an example of a rational number, because it will give you non-terminating, non-recurring decimal. Multiples of surds is also a surd. Now let's talk about how to manipulate surds. I think so we should be doing it here. How to manipulate surds means whenever you have surd in your question, how to simplify that. Okay, how can we manipulate surds? For example, whenever you have root of a, b, two numbers are multiplied inside the square root, you can write it to be square root of a times square root of b. This is very much evident from your law of indices, that if you have any power, you can distribute the power to the two numbers that are multiplied. Okay. Similarly, if you have square root of a over b, this can also be distributed and you can write it to be as square root of a over square root of b. Similarly, we must also know about the how can we deal with the reciprocal of this. For example, if you have 1 over square root of a over b, so we must know how to deal with it. It is actually in this way, 1 over, you can first distribute the square root on the numerator and the denominator, and then you can write it as 1 divided by square, because this is the denominator, so 1 divided by square root of a over square root of b. And then we know whenever you change the division to multiplication, we take the reciprocal of the second fraction, so it will be square root b over square root a. So that will give you root b over root a. So this is how you will manipulate your surd when you will be solving your questions. One more way of simplifying your surd would be, how can you simplify any surd? We know whenever we will be having any number inside the square root, how can we simplify it? Our aim should be that we should be making it into a form that 1 is a complete square. We get one number that is a complete square multiplied by the rest of the number. So as we know that 8 has factors 4 and 2, where 4 is a complete square. So you can first write it like this. Then by using the manipulating technique, that you can distribute the square root on both numbers, you can write it as square root of 4 times square root of 2, and we know the square root of 4 is a 2, so we'll write it to be square root 2 times square root 2. Secondly, let's take another example. Like we have, if any larger number also, you can find of 1 complete square times the rest of the number, the highest complete square, and times the rest of the number. So if you will check by hit and trial method, you will get this, that 144 times 5 will give you 720. Now what is 144? 144 is a complete square of 12. Okay, so first of all, distribute the square roots. 144 times square root of 5. It is a complete square of 12, so we'll get square root of 144 to be 12 root 5. This is your way. This will be your way of simplifying the surds. Next thing is how to do operations on surds. Means how to add surds, subtract surds, multiply or divide surds. So let's look into that. Operations on surds. If you have two surds added up, you can like 2 root 5 plus 7 root 5. You can only add them up if you have a common surd with them. If you have a common surd, you can just add up the coefficients like you do add in algebra the like terms. The common surd will make them like terms that you can add or subtract. So 2 root 5 plus 7 root 5 would be actually root 5 common, 2 plus 7, and that gives you 9 root 5. Similarly, if you need to subtract some surds, you can only subtract those surds which have a common surd, like 9 root 3 minus 3 root 3. You can subtract them because your root 3 is common, so 9 minus 3 gives you 6. 6 root 3 is the result of your this surd. Okay, now let's take an example. How can you simplify and apply this these addition and subtraction operations on surds? Let's do this with the help of an example. A question says root 125 minus root 45. Simplify this and give your answer in a root 5 form. Simplify and give answer So what is square root of 125? We know whenever we want to simplify any surd, we should first be considering that is it a multiple of any complete square? Like, can you distribute it in two terms with one largest complete square multiplied by the number, multiplied by the other factors? So you can check this, that this is root 125 can be written as 25 times 5 minus 9 times 5. Then see, in both of these numbers you have one complete square. Now by using the distributing surd technique, you will just distribute the square root on both the multiplied numbers. So it will become root 9 times root 5. It will then become 5 root 5 minus square root of 9 is 3, so 3 root 5. What is 5 minus 3? Because we have a common surd 5, so we can subtract these numbers. So 5 minus 3 is 2, and we end up getting 2 root 5. In the same format they asked us to find. Okay, this is the basic technique that we will be using to simplify our surds. Now let's talk about how to multiply surds. This was just addition subtraction. We can add and subtract if we have common surd. We can add or subtract. I'm saying it to be coefficients because these are like the numbers with the surd. So we can add and subtract coefficients if we have common surd. Now multiplication and division. How can we multiply two surds? For example, if you have 2 root 5 times 3 root 5, so it will be, you will multiply the number, the coefficient with the coefficient, number with the number. 3 2 times is 6, and we know that root 5 times root 5, you can write it like this. Then you can, if you have two separate surds, you can write it as one whole surd. So we can write it to be 5 times 5. We know that this is root 25, and this is 6 times 5, and that gives you 30. This is how you can multiply two surds. Okay, multiplying the numbers together, and whenever you have a common surd and it is multiplied like this, it will eventually gives you 5. Root 5 times root 5 will give you 5. Root 3 times root 3 gives you 3. Root 2 times root 2 will give you 2, because we get the square and the square root, that will cancel out. Okay, that will get cancelled. Okay, now the next thing is, what if you have 2 root 3 times 4 root 5? Means if you don't, if you have uncommon surds, common surds, uncommon surds. If you have uncommon surds, still you will multiply the number with the number and surd with the surd, and then you can write down as one complete, like multiply the numbers inside the surds together to write it as one whole surd. So it will be 2 times 4, 8, and then root 3 times root 5. This will give you 8 root whole square root 3 times 5, 8 square root 15. Okay, after doing this, if you will be able to get the product in terms of one complete square and one non-complete square, then you can do that and simplify it further. Otherwise, if it is not simplifiable, then you can just leave it as it is. So this is how you can multiply if you have uncommon surds. We will be talking about division, like what kind of a condition could be. Division of surds is not like a major subtopic, but just for your information. For example, if you have 2 root 5 divided by 3 root 5, so obviously if you have a common surd, that will get cancelled out, you will get the simple thing. Now what if you have an uncommon surd, like 2 root 3 divided by 3 root 5, then you can write it to be as 2 root 3 over, like you can't solve it any further because the surds are also, there is nothing common in between. If there is common, then you can cancel out by making first the one whole common surd and then cancel out the common things. But still, this working is not complete. Then what we actually do? Here comes the concept of rationalizing. So let's go talk about rationalizing, then get back to this division thing. What is rationalizing denominators? Whenever you have square root of any number in denominator, it seems that it is not it is not correct according to mathematics rules. So having root n in the denominator or having a surd in denominator is not acceptable in maths. Not acceptable. So how to solve it then? How to get rid of a surd in the denominator if we have that? So there are three things that possibly could be in your question. That you have 1 over root square root of any number n. If you just have one square root like this, a simple square root, then what you can do is you will be multiplying and dividing it with the same square root. This multiplying and dividing is called rationalizing. Okay. What if you have 1 over square root of a plus square root of b? Or what if you have 1 over a plus b square root b? Means you have both surds with a plus sign in between, or if you have two terms in the denominator but one is a surd and one is not a surd. In that case, how to rationalize it? You will always be taking the opposite sign in between. So you will be multiplying it with root a minus root b over root a minus root b. This is your rationalizing of such surds in the denominators. If you have any one surd and one non-surd, it's the same. You just have to multiply with the opposite sign in between the whole expression that is in the denominator. So it will be a minus root b over a minus root b. This is how your surds are rationalized if you have a surd in the denominator. So let's take some examples. First of all, taking the example of the same division thing that we had. See, we have a surd root 5 in the denominator. This is not acceptable. So what we do, we will rationalize it. Take this as an example for the first case. If you have anything like this, you will do it like multiply and divide with the denominator. So you will multiply and divide with 3 root 5 over 3 root 5. You can just multiply and divide with root 5 also. Okay, only if it is just a one number, so just multiplying with the surd itself is fine. So we'll end up getting 2 root 3 times root 5 divided by 3 root 5 times root 5. I told you, you can do the working, or you can, whenever you have two same surds multiplied, you will have the number itself 5. Then further solving it, it will become 2 root 3 times 5. We'll make it one complete surd, divide by 15, and that will give you 2 root 15 over 15. So we get rid of the surd in the denominator. That is your with the help of rationalizing. Now let's take one more example when you will be having two surds added up in the denominator. So for example, if you have roots 3 over root 7 minus root 2. Okay, here comes, if there is a plus, then here will be minus. If it was a minus, then it will be a plus. So I am writing it like this. If it was minus here, then it will be multiplied and divided with the plus in between. If it was minus here, then it will be plus. So if, as you can see, there is a minus in between. So how do we rationalize it? You will multiply and divide with root 7 plus root 2 over root 7 plus root 2. Now simplify this. 3 times root 7 plus root 2 over. You can see what form will it make? Always it will make the same form. This is a plus b or a minus b times a plus b. So it will end up giving you a square minus b square. So we have root 7 minus 2 times root 7 plus 2. It will become root 7 square minus root 2 square, because this is a minus b and a plus b. So a is your root 7 and b is your root 2. So this is how, now when you will solve it, you know that square and square root cancels out. So it will become 3 times root 7 plus root 2 in the numerator, and in the denominator it will be 7 minus 2. That will give you 3 times root 7 plus root 2 over 5. See, in this way of rationalizing, we get rid of the surd in the denominator. Yeah, that's it. Now let's take one last example, an example where you will be having, okay, we have done the example where we have both surds. Now let's take an example where we have in the denominator sum or subtraction, but you have one surd and one non-surd. So let's take this example when they say simplify 4 minus 3 root 3 divided by 5 minus root 3. So what we do for the rationalizing, we multiply and divide with the same denominator with the change sign in between. So 5 plus root 3 divided by 5 plus root 3. So this will give you 4 minus 3 root 3 times 5 plus root 3. Then we have again a minus b times a plus b. That means we can use the formula a square minus root 3 square. So always in the denominator we will be using this formula to solve it out. Then we will be having, okay, see how do we multiply surds? I told you just about the multiplication of two surds, individual like terms. If you have surds as brackets, so you will expand it in the same way we expand the algebraic expressions, where we have two brackets like x plus a times x plus b. Okay, so the same way, first term with the first term, then first term with the second term. So it will become 4 times 5 plus 4 times root 3 plus the second term with the first term. I am taking the sign inside. So minus 3 root 3 times 5 plus minus 3 root 3 times 3 root 3 times root 3. Okay, this is how you will multiply expanded brackets in the numerator, and the denominator you just solve. 5 square is 25 and root 3 square is 3. Now solve it further. 5 4 times is 20 plus 4 root 3, then minus 15 root 3 minus, you are multiplying 3 root 3 with 3, 3 root 3 with root 3. So 3 will come as it is, and root 3 times root 3 gives you 3. So it will give you 25 minus 3 is 22. Now solve it further. You will be adding up the surds, common surds together, okay, and the numbers together. So 20 minus 9 and plus 4 minus 15 is minus 11 root 3 over 22. So this becomes 20 minus 9 is also 11. So 11 minus 11 root 3 over 22. Now we can also check if there is anything common in between. And we can clearly see that 11 can be taken common. So 1 minus root 3 over 22. 11 and 22 can be simplified as 11 two times. So 1 minus root 3 over 22. Sorry, over 2. So this is your whole of the working for rationalizing the denominators. I hope you understand this whole topic. The next video will be about some of the topical questions about this chapter. We have covered all of the topics of your algebraic expressions topic. The main questions that come are from indices and surds, and this expanding brackets and the rest of the subtopics come like they provide a base for your working of some other topic questions. So that's all about chapter number 1, International A Levels EDEXCEL Pure Maths 1. Give us feedback in the comment section. Thank you and Allah Hafiz.